Number 10. Oumuamua. In October 2017, the Pan-STARRS telescope in Hawaii detected the first confirmed interstellar object ever observed passing through the solar system. It arrived at roughly 87,000 miles per hour, moving on a trajectory that proved it originated outside our solar system entirely. The object had no visible tail or coma, meaning it wasn't behaving like a typical comet, despite crossing close enough to the sun to vaporize ice if it had any. Its brightness fluctuated dramatically as it tumbled, suggesting an extremely elongated shape, estimated by some models at 10 times longer than it is wide. As it left the solar system, astronomers measured a small but unmistakable acceleration that couldn't be explained by gravity alone. Harvard astronomer Avi Loeb published papers suggesting outgassing or even artificial origin as possible explanations, though neither has been confirmed. No telescope managed to capture direct, high-resolution images before it became too faint to track, and it is now beyond recovery. Its composition and true shape never conclusively determined. Number 9. Betelgeuse. Betelgeuse is a red supergiant star, roughly 640 light-years from Earth, in the constellation Orion. It is so large that if placed at the center of our solar system, its outer edge would extend past the orbit of Jupiter. The star is in the final stages of its life and is expected to end in a supernova explosion, though the exact timing remains unknown and could occur anytime within the next 100,000 years. In late 2019 and early 2020, Betelgeuse dimmed to about 40% of its normal brightness, the most significant dimming ever recorded for the star, prompting speculation that it might be close to detonating. Observations from the Hubble Space Telescope later suggested the dimming was caused by an enormous cloud of ejected material cooling into dust, partially blocking the star's light. When Betelgeuse does go supernova, it will be visible in daylight from Earth and bright enough to cast shadows at night, despite the immense distance. Number 8. Sagittarius A star. At the center of the Milky Way lies Sagittarius A star, a supermassive black hole with a mass equivalent to about 4.3 million suns, compressed into a region smaller than the orbit of Mercury. A black hole is an object with gravity so strong that nothing, not even light, can escape once it crosses the event horizon, the boundary beyond which return is impossible. In May 2022, the Event Horizon Telescope collaboration released the first direct image of Sagittarius A star, assembled from data collected by radio telescopes across the globe, working in unison. Stars near the galactic center, such as the one designated S2, orbit this black hole at speeds exceeding 5,000 kilometers per second, completing an orbit in just over 16 years. Every star and planet in the galaxy, including the Sun and Earth, is slowly orbiting this invisible point, completing one revolution roughly every 230 million years. Number 7. TUN 618. TUN 618 is a hyperluminous quasar located roughly 10.4 billion light-years from Earth. A quasar is an extremely bright, distant object powered by a supermassive black hole, actively consuming surrounding gas and dust, releasing enormous amounts of radiation in the process. At the heart of TUN 618 lies one of the most massive black holes ever measured, estimated at around 66 billion times the mass of the Sun. Its event horizon is calculated to be roughly 1,300 times wider than the distance between Earth and the Sun. The quasar emits energy equivalent to roughly 4 trillion suns, making it one of the most luminous single objects ever detected in the observable universe. Because light from TUN 618 has taken over 10 billion years to reach Earth, astronomers are observing the object as it existed when the universe was less than a third of its current age. Number 6. The Boötes Void. Discovered in 1981 by astronomer Robert Kirshner and colleagues during a redshift survey, the Boötes Void is a roughly spherical region of space, measuring about 330 million light-years across. Redshift is the stretching of light toward longer wavelengths caused by an object's motion away from Earth, and it allows astronomers to estimate distance and map the large-scale structure of the universe. Within this void, fewer than 60 galaxies have been identified, compared to the tens of thousands that would be expected to occupy a region of that size based on the average density of the universe. If the Milky Way were located at the center of the Boötes void, humanity would not have known other galaxies existed until the 1960s, since the nearest galaxies would have been too far away to detect with the technology available at the time. Number 5. The WOW signal. On August 15, 1977, astronomer Jerry Eman, working with Ohio State University's Big Ear Radio Telescope, detected a narrowband radio signal lasting 72 seconds at a frequency close to 1,420 megahertz, a frequency associated with neutral hydrogen and considered a likely candidate for interstellar communication. The signal was roughly 30 times stronger than the background noise, and Eman circled the printout and wrote "Wow" in the margin, giving the event its name. The signal appeared to originate from the direction of the constellation Sagittarius, but despite dozens of follow-up observation attempts using the same telescope and others, it has never been detected again. No satellite, comet, or known terrestrial source has ever been confirmed as the origin. To this day, it remains the strongest candidate ever recorded for an artificial extraterrestrial transmission, and its source has never been identified. Number 4. The Great Attractor. The Great Attractor is a gravitational anomaly located roughly 250 million light-years from Earth, pulling our entire local group of galaxies, along with thousands of others, toward it at speeds of over 2 million kilometers per hour. Its existence was first inferred in the 1970s and 1980s through the measured motion of galaxies that could not be explained by visible matter alone. The region lies directly behind the plane of the Milky Way, an area astronomers call the zone of avoidance, where dust and stars from our own galaxy block most visible light and make direct observation extremely difficult. Using X-ray and infrared telescopes capable of penetrating that obscuring dust, astronomers have estimated the Great Attractor's mass at the equivalent of tens of thousands of galaxies. Its full structure and boundaries remain only partially mapped, and its exact nature is still debated among astrophysicists. Number 3. GN-Z11. GN-Z11 is a galaxy first identified in 2016 using the Hubble Space Telescope and later confirmed with the James Webb Space Telescope, observed as it existed just 430 million years after the Big Bang. Its light has traveled roughly 13.4 billion years to reach Earth, making it one of the most distant galaxies ever confirmed. Due to the ongoing expansion of the universe, GN-Z11's actual present-day distance from Earth is now estimated at over 32 billion light-years, even though the light detected left it billions of years ago. Despite forming so early in cosmic history, the galaxy has been found to contain a supermassive black hole and is producing new stars at a rate roughly 20 times faster than the Milky Way does today. Observing GN-Z11 means looking at light that began traveling before Earth, the Sun, or the solar system existed in any form. Number 2. The Hercules Corona Borealis Great Wall. Discovered in 2013 through a survey of gamma-ray bursts by astronomers Istvan Horvath, John Hakala, and Zsolt Bagoli, the Hercules Corona Borealis Great Wall is a massive structure of galaxies, galaxy clusters, and gas, estimated to span up to 10 billion light-years across. That measurement makes it, by some estimates, the largest known structure in the observable universe, roughly 1/10 the diameter of the observable universe itself. Its existence challenges the cosmological principle, a foundational assumption in modern cosmology that matter should be evenly distributed at the largest scales once distances are great enough. A structure of this size would theoretically take light more than 10 billion years to cross from one end to the other, longer than the age of most galaxies currently known to exist. Its full extent and structure remain difficult to map precisely due to its enormous size and distance. Number 1. The edge of the observable universe. The observable universe extends roughly 46.5 billion light-years in every direction from Earth. a distance larger than the age of the universe would suggest, due to the continuous expansion of space itself since the Big Bang, nearly 13.8 billion years ago. Beyond this boundary, space is expanding away from Earth faster than light can travel, meaning light from those regions will never reach us, regardless of how long humanity waits or how advanced its instruments become. The cosmic microwave background, the faint radiation left over from roughly 380,000 years after the Big Bang, marks the farthest and oldest light detectable, mapped in detail by missions including NASA's WMAP and the European Space Agency's Planck satellite. Current estimates suggest the true size of the entire universe, not just the observable portion, could be at least 250 times larger than what can ever be seen. And it may be infinite, a possibility that current physics cannot rule out or confirm. Every object on this list was found using real telescopes, real data, and real scientists working within the last century. Interstellar visitors, invisible gravitational giants, signals that never repeated, and light older than the Earth itself. All exist within a universe humanity has only begun to map. Most of it remains undetected, unexplained, or entirely unseen. Which of these unsettled you the most? Leave it in the comments. Don't forget to hit that bell and subscribe, and I'll see you on the next mission.